Hi, welcome. My name is Kugan from DKM5A. My metric number is 24 DKM22 F1063. Today, I'm here to present about my case study title, which is Utilizing PLC Automation for Workshop or Laboratory Efficiency Improvement. My group consists of me, Kugan, Prashant Ram, anak lelaki Sabamurti, and then Muhammad Aizat Daniel bin Muhammad Azan. So moving on to the introduction. Okay. Utilizing PLC programmable language a logic controller, automation can significantly enhance efficiency in workshops or laboratories by streamlining various processes and improving precision and safety. PLCs are specialized computers that automate repetitive tasks, monitor equipment, and regulate conditions such as temperatures, pressures, and motion. In workshop settings, PLCs can control machinery operations, synchronize production workflows, and reduce machine downtime, ensuring more consistent quality and output in laboratories. PLCs can be employed to automate testing procedures, manage sample handling, and ensure consistent environment conditions, thus enabling more accurate data collection and analysis. Overall, PLC automation contributes to time saving, cost reduction, and operational consistency, making it an effective solution for efficiency improvement in technical environment. Okay, let's move on to the next slide, which is problem identification. So in the workshop, it is standard procedure for students and lecturers to open the windows and turn on the lights prior to operating any machinery or performing any task. However, there is a persistent issue where they may be inadvertently leave the windows open after use, increasing the risk of animals entering the space, and this not only introduces potential safety hazards and contamination, but also risk damage to equipment as animals may chew on wiring, dispute machinery, or interfere with operations, leading to costly repairs and operational downtime. Furthermore, lights are often left on after the workshop is vacated, resulting in unnecessary energy consumption and elevated electricity costs. Okay, let's move on into a more detailed problem about animal intrusion. Let's move on to the safety risk, which is animals such as rodents or insects can pose health risks to individuals in the workshop. And then for equipment damage, animals can also may also chew on electrical wiring, causing short circuit and fires. Operational distribution: animals can interfere with machinery and equipment, leading to breakdowns and delays. For the second one, which is related to energy waste, increased electricity costs, lights left on unnecessarily contribute to higher energy bills, environmental impact, excessive energy consumption contributes to carbon emissions and climate change. Let's move on to the next slide. Okay, what is the solution that we came up with? Is an automated solution. It is essential that we use smart window actuators and lighting system in this situation so that we can successfully combine sensor-based mechanisms to control and maximize the operating hours of these parts. This guarantees a streamlined and controlled atmosphere in the workshop, in addition to energy efficiency. Okay, let's move on to the next one, which is components and software. Okay, first, what we need is smart window actuators. Components that we need to make a smart window actuator is motorized window actuators, sensors for detecting open or close status, and a central control unit. Second, we also require a lighting system. The required components are timer and a central control unit. For the third, we need is a central control system. The components we needed are a PLC board, also known as a programmable logic controller. And last but not least, we also need integration and programming software such as PLC programming languages like ladder logic or structured text to create the control logic. Okay, thank you. That's all for my part. I will be giving this next slide to my friend Prashant.
Thank you for that. Now let's move on to the workflow. Now let me give you an example of the workflow. So let's say for this project we are going to start with a switch button where we tap the switch button and the lamp turns on because the actuator extends and then the windows open, which then leads to us pressing the switch button off, which makes the window close and the actuator will retract, turning the lamp off. This is a simple circuit that we can understand. To give you a more brief explanation on it, the opening procedure is that when the workshop has opened, the students or lecturers only need to press one switch button to turn on the lights in the workshop. During the operation, only after the light is on, the window actuator tree will run and the windows will open automatically. The closing procedure, on the other hand, at the end of the day, the same button switch needs to be pressed again for the closing system. The windows will detect any impurities present in the windows and parts using sensors, and if it's all good, the windows will close, making the lights off. This is a simple understanding of it. Now let's move along. Now let me explain to you a little bit about the PLC programming automation window. Right, so an automation window starts with a push button and a lamp that will turn on after a start button is pushed. The lamp is turned on after 5 seconds. The sensor will be detected and give instructions to the actuator to activate it. The windows will automatically open. This is a table of the input and output table. Please look at it. So we have a few inputs and few outputs. We can start with the first table, which is input. The address will be 0.01, 0.00, which is the push start button. Input number 2 is going to be 0.01, which is the push stop button. Input number 3 will be 0.02, which is the sensor 1. And input number 4 will be 0.03, which is the sensor 2. And the last input will also be to sensor 2. It is 0.04 in address. It is to actuate the window 1, 2, and 3. That is depending on its one. Then there's four outputs for this system, which is output 100.00, is just the lamp. Output number 2 is 1.100.01, which is actuator 1. Output 3 is 100.02, which is actuator 2. And output 4 is 100.03, which is the actuator 3. Just to give you a brief explanation, this is the ladder diagram. I will dive further into it in a bit, but let me explain to you about the mnemonic and the workflow. Wait, hold on. So now let me explain about the rungs, okay, the rungs in this ladder diagram. All right, so the working principle of the ladder diagram is rung 1, when a push button as is displayed here, when your push button is pressed, the current will flow to the relay, which is IR, at 110.00. The push start will be released and the current continuous flow will flow to relay. All right, because of the latching. If you press stop, the lamp and the window will be closed. All right, now take a look at rung 2. In rung 2, the current flow from relay IR 10.00 to the output, that is the lamp. The lamp will be turned on if this were to get the current flow. Rung 3, all right, the lamp is turned on and the current continues to flow to the timer. The timer will be set at 5 seconds. Okay, Rung 4, 5, and 6 is somewhat similar, as after 5 seconds, each of the sensor will detect the current from the timer and each sensor will function. So it's rung 4, 5 seconds detect the sensor, rung 5, 5 seconds detect the sensor, rung 6, 5 seconds detect the sensor. Now let's move to rung 7, 8, and 9. The last three rungs, the current flow from the sensor and give instructions to each of the actuators. The actuators will then be activated and the window will automatically close. The program interacts with the automatic system windows by coordinating each of the device in a simple time sequence and safety overrides. All right. Um, First, it waits for the button to be pressed. Once it's pressed, the program turns on the lamp, visually indicating that the system is active and starts its sequence. The program then initiates a 5 seconds of delay using an internal timer, giving a buffer period before any further action is taken. After the delay, the program checks the sensors and determine if there's any required condition that have been met. If it's not, it will signal the operator and for the workshop. If it is all good to go, then the program works as per normal. Like detecting if the sensor gives a positive signal, the program sends an output command to the actuator, which then opens the window automatically. This movement of the actuator opens the window into the desired position of where you want and want, fulfilling the program's goals in the cycle. Throughout the sequence, the program is continuously monitors by the stop button. If the stop button is pressed at any point, the program overrides its current operation and immediately turns off the lamp, signaling the end of an activity or the program. It also commands the actuator to close the windows, ensuring safe and controlled shutdown. Now, let's take a look at the mnemonic code. The mnemonic code is here for your reference. Let me explain to you a little bit about the mnemonic code. The mnemonic code is shown, okay, for this program. We just show you. You can see there the start button, the on off button, the IR, the lamp, the sensor 1, 2, and 3, and the actuator in 1, 2, and 3 in each of the windows. Now talking about the flow chart, okay, now in our programmable logic control, a flow chart is essential for us. So the flow chart for this program starts with, of course, a push button. Okay, a start push button is start, which turns on the lamp. Okay, by turning on the lamp, a timer is initiated, the 5 seconds timer, which then detects by all three of the sensors, sensor 1, 2, and 3. Okay, if the all three sensors detects, and all the actuators for each of the sensors will be detected as well. So sensor 1 to 3 will detect actuators 1, 2, and 3. The actuator will then push the window to be open and the push stop button, and then if anything, then we click the push stop button, it will shut down the entire program. This is the end of our flowchart. To come back, do a wiring and troubleshoot if the sensors did not get the signal. If the sensor did not get to to give a signal when the lamp is turned on, that means it's a problem. And if that's a problem, we have to do troubleshooting again. And then for us to concentrate, we have to go back and start the push button. If sensor 2 is not and sensor 3 is not, everything works the same. We do a troubleshooting. All right, that's all for me. Thank you. I'll pass it to my friend Haizat.
Thank you, Prashant. So next is objective and solution. The objective is to test the evaluate a solution that effectively ensure window are closed and light are turned off after workshop use, and minimizing the risk of animal infraction, preventing damage to equipment, reducing energy consumption, and lowering operational costs associated with connect with unnecessary repair and electricity usage. Second is test criteria and feature. First is hands-free operation. Second is safety features, obstacle detection. Third is consumption closure after each session. Fourth is motion activated for activated or time-based control. Uh, Next is manual uh, override option, and the last one is consistent and reliable operation. Next is test procedure and evaluation criteria. First is to install automated or alarm system and test them by leaving window open at various interval. Second is to install automated light lighting system
or use manual checklist for light. And the last one is record uh, compliance rate and collect use feedback. The last one is success metric. No window. First is no window left open after workshop use. Second, significant reduction in light after on. And the last one is at least 90% compliance after all user, student and lecturer in adhering to new procedure. Okay, for the discussion and conclusion, implementing for discussion, implementing effective procedures and training is essential for ensuring that users follow workshop rules like closing windows and turning off light. This this is important for safety, efficiency, and saving energy. One major challenge is getting everyone to behave consistently, especially since different people use the workshop at different time. Regular check and inspection can help remind user to stick to the rules and the explain the rule, but also engage user to so they understand why this practice practices matter. For example, training can show how following this protocol can lower energy costs, benefit the environment, and protect equipment when training is simple and interesting. Users are more likely to remember and adopt this good habit in their daily routine. For the conclusion is uh, in conclusion, clear rules and good training are key to getting user to follow workshop procedure like closing window and turning off the light. Regularly check help to build this habit while easy to use. The system make it simple for everyone. Approach save energy, reduces risk, and keep the workshop safe and efficiency. Uh, thank you very much. Okay, thank you very much and very good night. Bye.